अस्सलाम वालेकुम फ्रेंड्स, वेलकम बैक टू आवर यूट्यूब चैनल। उम्मीद है कि आप सब लोग खैरियत से होंगे। आज का जो हमारा टॉपिक है वो है द कोर्स ऑफ रिएक्शन। यू मे बी एबल टू कैरी आउट एन इन्वेस्टिगेशन इनटू द रेट एट विच सबस्ट्रेट इज कन्वर्टेड इनटू द प्रोडक्ट ड्यूरिंग एन एंजाइम कंट्रोल्ड रिएक्शन। Figure 3.5 shows the results of such an investigation using of enzymes catalase. This enzyme is found in the tissue of most living things and catalyzes the breakdown of hydrogen peroxide into water and oxygen. Hydrogen peroxide is a toxic product of several different metabolic reactions, and so it must be got rid of quickly. It is an easy reaction to follow as the oxygen that is released can be controlled and measured. The reactions begin very swiftly. As soon as the enzymes and substrate are mixed, bubbles of oxygen are released quickly. A large volume of oxygen is collected in the first minute of the reaction. As the reaction continues, however, that the rate at which oxygen is released gradually slows down. The reaction gets slower and slower until it eventually stops completely. The explanation for the course of the reaction is quite straightforward. When the enzyme and the substrates are different mixed there are first mixed, there are large number of substrate molecules. At any moment, virtually every enzyme's molecule has a substrate molecule in its active site. The rate at which the reaction occur will depend on how many enzymes molecules there are and the speed at which the enzymes can convert the substrate into products, release it, and then bind with another substrate molecules. However, more substrate is converted into products, there are fewer and fewer substrate molecules to bind with enzymes. Enzymes molecules may be waiting for substrate molecules to hit their active sites. As a fewer substrate molecules are left, the reactions get slower and slower until it eventually stops. The curve of graph such as the one in figure 3.5 is therefore steepest at the beginning of the reactions. The rate of an enzyme controlled reaction is always fastest at the beginning. This rate is called the initial rate of reaction. You can measure the initial rate of reaction by calculating the slope of a tangent to the curve as close to time zero as possible. An easier way of doing this is simply to read off the graph the amount of oxygen given off in the first 30 seconds. In this case, the rate of oxygen production in the first 30 seconds is 2.7 cm cube of hydrogen per 30 seconds cube of or 5.4 cm per cube of per minute. Figure 3.5 shows the course of an enzyme's catalysis reaction. The catalysis was added to hydrogen peroxide at time zero. The gas released was collected in a gas syringe, the volume being read at 30-second intervals. ये हमारे पास ग्राफ है। जो टोटल वॉल्यूम हमारे पास जो कलेक्शन हुआ है वो हमारे पास वाई एक्सिस पर है और जो टाइम है वो हमारे पास एक्स एक्सिस पर है। वो हम देख सकते हैं ग्रेजुअली इंक्रीज़ हुआ है और उसके बाद स्लो होता गया है। इंक्रीज़ तो हुआ है लेकिन विद द स्लो रेट, यानी ऑक्सीजन की जो प्रोडक्शन है वो स्लो हो गई है। ठीक है ना। तो आज जो हमारा टॉपिक था वो था द कोर्स ऑफ रिएक्शन। उम्मीद है कि आज का टॉपिक हमारे व्यूअर्स को समझ आ गया होगा। मिलते हैं आपके साथ नए इन्फॉर्मेटिव टॉपिक में। सब तक के लिए अल्लाह हाफिज़।